Okay, great. So again, bonjour, and I guess it's bon après-midi now. And we are just as by intro, we are going to talk about a few things. We'll talk about ourselves and like who we are and how we got basically inspired to be part of working in the space industry. And then we'll talk about climate change, which is the motivation for why we started the challenge. And the challenge has been going on for 4 years or for different years now. And for this particular one, we're focused on methane. And so Eric will talk a little bit more about the problem area that we're trying to address. And then I will end with just the mechanics of how you can actually participate in the competition. So I think that's sort of like the agenda that we have prepared today. And then afterwards, ask any question. And also feel free to interrupt us if you have a question during the actual presentation, since we're a small group and we can certainly just do this more as like a discussion.
And the first part is just our personal story, so that we can wait and see if our friend can join.
Yeah,
it won't miss anything.
Okay, so let me just like start. So I'm Emmeline Dahlstrom. I am actually Filipino and also American, because I lived most of my life in the Philippines, and then I immigrated to the US after also living in Europe and in Canada. My background is physics and space science, but I really mostly worked on program development, operations, educational management, mostly on the tertiary and postgraduate level. Worked with the International Space University and Singularity University, which is like focused on basically graduate level space education. And also exponential technologies. And then I also worked for space startup companies in the US, ranging from basically space tourism. So 20 years ago, we sent space tourists to the International Space Station, all the way to working with startup companies that are working on building like landers and rovers like to the moon. Eric.
Yeah, I'm Eric. I'm from the US. I started studying physics and astronomy and mapping the galaxy with radio astronomy. And then I went into space engineering and worked for many years for NASA on space station design and some other projects, working for big companies like Lockheed and Raytheon. And then I was involved for many years with the International Space University, which is how Emmeline and I met.
So we were both students.
And so the International Space University moves around the world and is hosted by different cities. And it's going to be it just started in Brazil. And so I'll be
for this year,
and I'll be going over there next month. So in California, we were helping lots of space startups get created, and but we've always been interested in international space activities.
Which is why, even though we are actually based in New Zealand today, we still maintain our global space community network, and we're still working with projects that are actually based in the US. So really, our story is that like 6 years ago, we actually moved to New Zealand because there was a program called the Edmund Hillary Fellowship Program, which was for entrepreneurs and investors to come to New Zealand and work on a scalable project and impactful project. And so our project basically was incorporating and creating SpaceBase. And so SpaceBase is really, I think about it as a purpose-driven consulting, because we're a social enterprise that's really focused on the democratization of access to space. And when we say that, the reason that we are kind of like focused on this is that we are, oh, actually, I think your other, let me just admit the people that are online. All right, I think they're now
which is good. They just missed the art introduction. That's
which
that's
is which is good. So yeah, as I was mentioning, the SpaceBase, we created SpaceBase, and the reason was that it's on the premise that, you know, space or space industry, the global space industry, will be, you know, pivotal and important to kind of like the future of humanity. And if we really believe that, we want to make sure that nobody gets left behind, and so that all of the opportunities are actually given to everybody around the world. And so that's sort of like why our main focus is creating space ecosystems and growing space industries, particularly in developing and emerging countries. And so we thought that coming to New Zealand, we could prototype and understand how it is to kind of like do this. And we do this through, you know, education, entrepreneurship, and community building through the past like 5 years that we've been kind of like in New Zealand. And then, so one of the other things that we always get asked is that, you know, why even focus on space when there are so many problems like on Earth right now that we can potentially be focusing on. But, you know, besides the general like rockets and rocket ships that are very visual about the space industry, what we're really focused on is leveraging space technology to solve like grand challenges on Earth. And so, which is why, like, if you look at the United Nations Office of Outer Space Affairs, each one of those UN SDGs are actually represented in their website, and that space technologies are actually being leveraged to basically address those UN SDGs, from you know, looking at the health of planet Earth through like the weather, you know, disaster relief, like wildfires, and then there are other things as well, like methane sat, and we'll talk about methane in a little bit, just to understand how that 90% of actual climate change monitoring is now actually being done by satellites. So other applications as well that are also focused on Earth today, like in New Zealand, there's this company that called Starboard, and they can now also monitor like shipping lanes, which then can also monitor like illegal fishing, or also biosecurity as well. And then in terms of precision agriculture, now there's just the satellite applications are now, and the sensors are now very sophisticated, that they can count trees, they can count fruits, they can actually see mostly like the health of plants as well. So in general, what we always think about the space industry is really all of the segments of the space industry, and all of all parts of the supply chain, not just building rockets or building spacecraft. And I just wanted to point out as well that if you look at the global space economy today, which is over almost $500 billion, the kind of like the pie, the biggest part of the pie there is really on services. So this is what we call downstream, where remote sensing and data applications are really where the opportunities are. And at the same time, it's also that the opportunities are lower hanging fruit, because capital is not as intensive when you're focusing more on data and software.
And a big part of this, the motivation, and even for us, when we were in California, we were seeing the opportunities that come from these exponential technologies, these technologies like computing that are advancing very fast, doubling every couple of years. And so it not only is it, driving powers of computers, but also suddenly you have all these AI applications appearing, within months and things like that. So there's a tremendous power that's been advancing in the computing area that has been spread to lots of people around the world, and we just want to make sure that people are able to take advantage of this. And so another thing that has been happening is the sensors on the spacecraft have gotten a lot better at measuring the health of plants or small deviations, even in changes in the environment, and as we mentioned, the tracking of ships. And so these things that all these elements that used to cost, tens of thousands of dollars long ago, access to the satellite data or the analysis software or the computing platform, they've all been reduced in cost and increased in capability, so that,
And they've been open source.
yeah, and so like the software is now open source for many of these applications, and the access to the data is opened up, and your own computer is more powerful than what the specialized computers we used to use at NASA. And so this is why our motivation for opening these challenges up and saying, and hoping to communicate to the people that and students that they have the power to address these global problems with their own computing power. And so we've tried, over the years in New Zealand, we've tried all these different efforts in activities to support this growing space ecosystem. And the challenge competitions is something that we've focused on as a good way to trigger lots of activity, bring in new people, and actually solve a problem you pose as a problem. And so there's a long history in aviation and space of prize challenges, even going back to Charles Lindbergh almost 100 years ago, with triggering the aviation industry. And so when you set out a prize challenge, you get a dozen different approaches in potential solutions. So our last challenge we ran, we had 20 potential solutions to, in that case, it was how much carbon is being sequestered in trees and vegetation. And we had, it was building partnerships around the region. And actually the winner was from Fiji, and did a great job about being able to use satellite data to quantify how much carbon is being sequestered in trees. So some of these different solutions from our challenges in the past, we had people running around with lasers measuring trees in Australia, and connecting with lasers from space. We had people able to detect pollution using watching just the color changes in lakes. I had students monitoring the health of coral reefs with remote sensing data, and the down here is the one from Fiji, where they were actually using high resolution data and be able to measure for individual trees. And so on this challenge, we're once again focused on climate change, and you're quite familiar with the increasing heat that's going into the Earth system caused by the greenhouse gases, and that putting all this energy into the Earth environment is changing weather patterns, is drying out regions, is moving water around to other regions, increasing the chance of fires in across Canada right now, things like that. And so all these caused by the emissions of these greenhouse gases, the most of the effect is and most of the problem is the carbon dioxide, but methane is an important piece of this. And the methane is actually identified by the IPCC and the scientists as saying, if you can, it's the most cost-effective near-term solution to reduce global warming. And just as we have different lecturers and record different experts talking about this, and I keep stealing charts from them to add to this presentation, but this is the spectrum, the visible light and near infrared, showing where methane is detected. And these near infrared ones are where the satellites usually measure the emissions of methane, but it's really over here in the farther infrared, in the thermal infrared, where the warming effect happens from methane blocking this light from being emitted from the earth and acting like a blanket to hold in the heat. And so so the methane is incredibly powerful, more powerful at blocking heat than carbon dioxide. And so, and there's different sources, like from agriculture. Each cow can emit like 100 kilograms of methane per year. Industry is the biggest source, and then you have other sources like landfills that emit methane. Of course, there's on the global scale, there's huge emissions from the big countries, but it's a problem that many of the countries are very concerned with. But if any tools that we find in our challenge, we can instantly apply to around the world. And so this is some of the big methane sources that are mapped using some of the freely available data. And you can see that there's industrial areas and pipelines are major sources. And if you zoom into our area, there's some, Australia has a number of emission sources from especially old mines that still emit methane, and there's less emissions in our area, but everything that we detect in this challenge, we can apply across the world. And so this is sort of the whole methane cycle, with the natural sources over here on the right in green, and then the human emission sources with the industry and agriculture and biomass burning over here contributing on the left. And quite a bit of this human emissions are being absorbed in the natural system, but there's still this 10 million tons. It continues to grow. And so methane has been crawling up, increasing in the density in the atmosphere. So we have in New Zealand, there's a concern about the agriculture emissions, and they have elaborate procedures where they put sheep in boxes and things like that, and measuring and quantifying the methane emissions from livestock and pastures. But it's the aim is for us to really observe these things directly from satellites would be the ideal. And so this is at a lower resolution from the satellites that show the concentrations of methane across New Zealand, and New Zealand in particular does not a bad job on carbon dioxide compared to other countries, but methane accounts for half of the greenhouse gas contributions. So there's a number of satellites current and planned for monitoring methane, and quite a few of them, the major ones, are freely available data, and that's what we're offering as a start for for this challenge is for people to use some of these data sets that are out there. And this is in some, we're preparing analysis capability for next year's, there's a satellite methane sat is going to be launched, and it's partly funded by the New Zealand government, and it sort of fits in this in between the broad global mapping and the very specialized point source mapping, and but they still need to target the satellite, and so the scientists are asking us to help identify where they should target the satellite to monitor the methane emissions. And so these are details about the satellite, but it's basically, sectors of, 200 kilometers on a side and about 100 meters resolution. So you can see it's being built and getting ready for launch. So this is the problem statement for the challenge. We're using satellite data in combination with other data sources, help develop scientific methods to identify target areas of methane emissions on Earth. We're keeping it very broad so that we can get different approaches, different ideas for this, and basically we're asking for things that help advance the research in these areas, and we'll be leaving having our judging panel decide, who has got ideas that can move these things forward and advance the work on this.
Yeah, and this year as well, we're using one problem statement, because the last time we actually had a different problem statement for the two categories, for high school and then for university. But this time we're using the same, basically the same problem. So kind of like to wrap up the last section here is for me to basically talk about the mechanics of the challenge in itself. So in a nutshell, there are really there's 3 stages to the challenge. One is to basically get into the incubator, which is stage 1. Stage 2 is basically to down select to the finalist that will then compete in stage 3, which is not until the 15th of March 2024 for the grand prize, and that the proposals for getting into stage 1 is basically open today until the end of August. So as I mentioned, there are 2 categories. There's high school and university, and the judges for both are different. So and of course, the level of expectation is also going to be different, even though the problem area is the same. And really the requirements is just you either are a high school student or a university student, and whatever level, or a startup. And for simplicity's sake, when we talk about startup, it's just that you need to be no more than 20 in your organization. And then also that you're a resident, or basically you live, doesn't necessarily, don't care about what kind of visa you have, but as long as you're resident or living in New Zealand, Australia, the Pacific Islands, including the Philippines, during this time frame of the challenge. So as I mentioned, the stage 1 is for the virtual incubator, and we're selecting essentially about 20 teams from both of the levels. It's gonna run, and it's basically virtual, so it's all online, between October to February of 2024, where there is also a break in between for the holidays in December. What's in the virtual incubator? There's webinar sessions that will talk about or with specialists that will talk about the problem area, to those that are already working in the area for current solutions, some basically tools and skills for remote sensing. We're also in the process of getting potentially an aggregated like platform for the satellite data that could be utilized. And then of course, we're gonna look at mentors for those teams, depending on where they are and what they need. And the reason why we do this incubator is basically we want to help the teams really work on what they're going to be submitting as their final application. So really the first part is you're just really giving a proposal. And so the requirements for this is just two. So basically one is like, who are your team members? So, you know, the CVs or resumes of your team members. And then the other one is like a proposal. So the proposal would then include just the idea or the general idea of what you want to do, what problem specific that you're addressing, what's your plan and schedule, and then also what support you're basically needing. And so this proposal is due at the end of the 31st of August. And yeah, you can just go to the SpaceBase website where there's a button to kind of like click on the form. And then on this stage 2, which is then going to be, the deadline is February 25. This is where everybody then would submit like a full application. And what we're doing is that we're expecting that the teams from the incubator to submit applications, but also there's a workaround where if you did not get into the incubator and you still want to submit an application, that's also okay. And so the requirements are just, again, two things. One is like, it's just a 5-minute video demonstrating your solution. So it's a proof of concept. And then the second one is a presentation deck, basically describing what you've actually done. And so what we're doing is that we're down selecting to 3 finalists for the high school level and 3 finalists for the university and startup level. And so those ones, if you actually get into the finals or if you get into the finals and you're a finalist, there's already, you're already guaranteed that there's some kind of cash prize that you're actually going to receive. And so the final stage is that pitch and demo session during the 15th of March, where then you compete for the grand prize, which is like 25,000 New Zealand dollars for the university and startup, and 8,000 for the high school. And then the finalists will get some cash prizes as well. So in terms of the judging, so basically the criteria is the same for all of the stages. And just so this is just simplified here, where there's really basically six elements. So one is, are you using space technology? So which is a given. But you can also use a combination of like space technology and maybe ground data as well. Second is like, is your idea like feasible? Is it scientifically based as well? So then the other is like, is it a new idea? Is it, it hasn't been kind of like done before. Ease of implementation is one, like how easy is it for you to actually implement this? What's the environmental impact? Is it small or large? And then there's also, for the prototype, that's for stage 2 and stage 3, when you're actually showing either in video form your demo. And then the last 3 here is basically extra points. So you get extra points if there's evidence that what you're trying to do is implementable and the impact you can see in 3 years. The other thing is like, if you're collaborating with other stakeholders or you're collaborating with other organizations, that's actually a plus. There's also the creative integration, meaning that if you're not just using space, but you're also integrating other industries or other like scientific disciplines into your idea. And then the third one is team composition. So does your team have got what it takes to actually get it to the finish line? So I actually, those are everything that's on the mechanics. And I just wanted to point out and thank our sponsors and our partners, of which, of course, the government of New Caledonia through Mr. Mulyava is a big supporter. And so we thank you for promoting the challenge. There's also Decal Technopol, of course, who is hosting this particular briefing. And yeah, so we have partners and sponsors from all across New Zealand and Australia and the Pacific Islands, and we're still looking for funding as well, because we haven't finished our fundraising for the operations of the challenge. This is where you can basically email us. Yeah, we're looking for applicants. We're looking also for, if you're an expert and would potentially either will be able to even like mentor like maybe the high school level is also an option. And then, yeah, we're also looking for sponsors. So I think that's it. Yeah, and again, this is the link to the platform, or just go to SpaceBase.co and then you'll find the button to actually apply. So I think I will
just
stop and we can do questions.